I created this effect. It's kind of just a little modeling toy that I found kind of fun in this. And I'm going to increase the speed of it just a little bit there. It reminded me so much of the Astral Spike from the video game Control. I'll show you how to produce this effect. But this is a shot from it. It's from Goosey Schmoo's channel on YouTube. They got one of the best views. One of these things moved for a little while. Now, this effect that I have up here is something that I can modify. So I can change how fast it moves to the different points, because it's basically just taking 100 points around it that it produces at random, and then taking every vertex inside of here, finding out which point is closest, and lerping it towards it each frame. But because it changes every frame, that means the direction also changes. So if I go to 100% or 1, you can see that it finds like 3 or 4 that everything is closest to, and then produces that. But if I make it slower, then that tug is much slower as well. So if I go down really low, like 0, then there's nothing happens. And there you see it changing much more slowly. Okay, so let's dive into the actual code to see how this is made. 52 lines of code. This is just a toy. It's not for high performance anything. If we really wanted higher performance, this should be done in a shader anyway. If we have the mesh filter, what are we actually going to manipulate? Point range, it's how far around the points are going to be. So it's up to 2 meters in any direction. We have the lerp, then we have the points. These are the random points we're generating that it's going to try to find things close to it, and it's generating 100 of them. And we've got the vertices original. We want to know that original sphere shape, because remember, once it gets to like a triangle where you only have 3 points, if there's 3 points, then on average it's like 33 points per vertice. And those are not going to separate out. So what we need to do is every single time we're trying to figure out the direction and target for each vertex to lerp, we want to start over from that beginning shape again. We clear any points that we had, because every single frame we're constructing a new set. So we're going to get a list of the vertices of its current state. We want to know its current state as well. We could use that sphere shape, that initial sphere shape like I was talking about, because this is a slightly complicated concept. We're using both the shape that it's in now, and we're using the shape that it started in, as well as the random direction we're trying to get it to. That's 3 shapes that we're effectively merging together. I'm just going to go through every single one of the vertices, its current shape. I'm going to go through its current shape for the count. Let's see, vertices, but I'm not actually going to be using that. You can see that none of the stuff inside of here where it's doing the math actually uses it, except for setting the value according to a lerp from where the current position is to what we define as the closest point. But the closest point is actually coming from the original. So we're lerping from our current position to the closest point that we find somewhere between this new random target and the original shape. Okay, so inside of here, we effectively go through every single one of those points until we find whichever one is the closest one. And once we have that, that's when we do our lerping. That's when we use set vertices to put it back into the mesh. Anyway, I hope you found this useful. I'll talk to you later.